Welcome to my videos, and today we'll be doing Laplace transformations, and we'll be solving Laplace transformation using first principles. So what Laplace is, we'll be transforming an equation of f of t into f of s, and we'll be doing it using this formula above. So without any wasting time, let's solve that. Our f of s equals to integral of from 0 to infinity. Our f of t equals to 4t and multiply by e to the negative st dt. So since well 4 is a constant, we can put it in front. So it's t multiplied by e to the negative st dt. And right now we're going to use integration by parts. So integration by parts states that if we integrate u dv is equals to u v minus integral of v du, right? So now we're going to let our u be equals to t. So that means our du equals to dt, right? And then if we let our u be equals to t, then that means our du is going to be the remaining of that equation, which is e to the negative st dt, and we're going to integrate both sides. Put integral sign both sides, e negative st dt. So that means our v equals to e to the negative st all over negative s. So now we have found our u, our dv, and our v. As we said, it's u v. So our uv, our u it's t, u and v it's e to the negative st all over minus s. Negative integral from 0 to infinity of, so in this case it's going to be our e right dt. So let me explain it further. Remember we said our our u it's t, our therefore our du equals to dt. So whenever we see du, which here it is, we're going to substitute dt, of which I did here. It's the same thing, but then I'm trying to work with only one variable. So not one variable, the same variable, excuse me. So now let's integrate the remaining one. Also this one is from 0 to infinity minus, now when you integrate this thing, it's going to be the same thing. It's going to be e to the negative st. This is minus s. So now I'm going to divide again by negative s. So that means it's going to be positive. So now it's going to be positive x squared because I have divided by negative s again. I hope I hope we understand each other. Now this ranges from 0 to infinity, right? And we're going to substitute our t with what's on the top minus what's on the bottom. So in this case, it's going to be negative. It's going to be infinity minus whatever that answer we get when we substitute 0. So the first one, it's when we substitute infinity here. When we substitute infinity here, when we substitute infinity here, a is going to tend towards 0 because the more you increase it, the whole function decreases. So it eventually tends to 0. So it's going to be just 0. And then when you substitute 0 here, everything becomes 0. So it's 0. So it's going to be minus 0. And then now I'm doing the same thing here. When you substitute infinity here, as I said, it's 0. And now when I substitute 0 here, it's going to be 1 over s squared. Now final answer is 1 over x s squared. So this is the answer. I hope we are together so far. So let's do the next one. Let me rub in here. Let's do the next one. So the next one is, excuse me. The next one is f of s equals to, it ranges from 0 to infinity. So now we're going to substitute e to the 3t e to the negative st dt. So now we have the same base. We add the exponents. So it's going to be negative that ranges from 0 to infinity. E that's going to be 3 t minus st dt. I hope that makes sense so far. But then I'm going to take out the common factor, and then I will show you why I've taken out the common factor of negative 1. So I'm going to put it as e to the negative. So let me just put st minus 3 t. So again, you could see like there is a common factor of t. So instead, let's take a common factor of negative t. So now it's negative t, right? dt. Now we need to integrate. I'm still gonna show you how why I've taken out the the common factor of a negative t. It's going to remain the same here when we integrate it. It's going to be all over. It's going to be all over negative. It's like you take everything but t, you divide it by it. Now this one ranges from 0 to infinity. And the reason why I've taken out the negative t is because now when I will be substituting infinity at t, it's going to approach to 0. It's like what we did before. It's going to turn into 0. So the first one, we know that that one tends to 0. It's going to be 0. You could write it minus, now it's going to be 1. It's going to be 1 because of when you substitute 0 here, when you substitute 0 at t, it's going to give you the whole thing 1 over negative s minus 3. And the final answer, this negative, they will cancel. It's going to be 1 over s minus 3. And as you can see, we did it by first principles. And as you can see here, our f of t was equals to e to the 3t. And we recognize there's a 3 here and there's a 3 here. So if ever we say our f of a, sorry, not f of a, our f of t is equals to a at, then that means our general formula is going to be 1 over s minus a. So if ever your a is 5, if ever your a is e 5t, that means your answer is going to be s minus 5, right? And if it's, let's say, it's going to be, if it's negative 3t, then that means it's going to be, the sign is going to change. It's going to be positive 3. So I hope I do make sense. That's this far. I hope I do make sense, because these things are not difficult, really, are not difficult. So let's do the last one. It's, yeah. So the last one, it's, we are required to transform this equation to f of s. So it's going to be a long one, but then it's not that difficult. We use the same formula from 0 to infinity cos of t e to the negative st dt. So we're going to remember what we did in number 1. We're going to let our cos t be equals to u. Therefore, our du equals to minus sin t dt, right? So that means our dv, it is what remains here. So it's e to the negative st dt. So when you integrate both sides, it's going to be our v equals to e to the negative st all over negative s. So our u it's cos t, our v it's e mm, e to the negative st all over negative s minus an integral of from 0 to infinity of, now it's going to be e negative st all over negative s negative um, multiply by negative st dt. I hope it makes sense. But then you still have to simplify. It's not done here. You still have to simplify this. So this one is cos t e to the negative st minus s plus, because of, no, this negative they cancel. Let me just rub them, and now I'll be left with negative. So it's going to be negative. I'm taking 1 over s as a common factor. 1 over s because it serves as a constant. So it's going to be from negative from 0 to infinity of e to the negative st minus sine t dt. See, now I have to do the same thing that I did. I'm letting my sine t be equals to our du, therefore it's equals to cos t dt, right? And our u, sorry, our dv is equals to e to the negative st dt. And then we're going to integrate both sides. Our v is equals to e to the negative st all over negative s. So I hope it makes sense so far. So now I'm substituting, right? And I don't know where to write. Let me do this. How do I move this thing? Trying to move this text here so that I can write it, but then it's fine. Let me proceed. So it's cos t e to the negative st all over negative s, right? Now I've taken out this as a common factor. So now I'll be writing the same thing that I was doing all along. When you integrate, when you integrate u dv is equals to uv minus I v du. So now I'm substituting that. So my u is sine t e to the negative st all over negative s negative from 0 to infinity of, now I'm substituting these ones. I'm substituting these ones. It's v and du. So it's e to the negative st all over minus s. You multiply that with cos. So it's cos t dt. So let me wrap it here. So also let me try to put it in the simplest form that you can understand. And let me simplify it. So now we are saying it's cos t multiplied by e to the negative st minus s negative. Now this is sin t e to the negative st all over s squared. So now this is going to be positive because of this negative, and this negative is going to be positive. And this negative and this negative is going to make it positive, and this negative is going to make it negative. So it's going to be minus, right? It's going to be 1 over s squared because of this one and this one. When you multiply them, give you s squared. So now it's going to be an integral from 0 to infinity cos t a negative sine negative st dt. So when you look, this one, this thing here is the same as that question that we were asked. Remember, let me put it here. Remember, we asked to we were asked to integrate this, and this one and this one, they're the same. So I can move this one to the other side. It's going to be 1 plus, let me say, so this one is a 1 here. So when this one comes to the other side, it's going to be 1 plus 1 over s squared. Then you add e to the negative st dt cos t e to the negative st all over minus s plus sine yeah, there we go. Now we're going to divide by this because we are only looking for this. So when we divide by that, our integral is going to look like this. It's cos p s. Let me rewrite this quick. plus sine t all over sine squared, sorry, s squared, all over 1 plus 1 over s squared. So all of this, it ranges from 0 to infinity, right? So I hope we are still together up to this far. So in this case, we integrated both sides. I mean, uh, both cos and sine. We integrated twice, and then we were able to see that this. Let me use a different color. Let me use purple. See, no, not purple. Let me use blue. We saw this one and this ones are equal. So it's like x. It's like when you have an equation where it's 3x equals to, let's say y, well, for that case, and 2x. So these are like your variables. So that means you can only subtract these ones. So that means this one is going to be when it comes to that other side is going to be this. So same thing here. It's literally what happened. Now I'm going to substitute my infinity and 0. So let's start with infinity. When you substitute infinity here, it gives you 0. When you substitute it there, it gives you 0. So first one is 0, and because of we have 0 here, and cos of 0 is wait, am I being correct? Let me do this. Let me do this. I'm substituting the whole thing. I'm substituting the whole thing, the infinity into the whole thing, and then I'm going to subtract, and I'm going to do the whole thing again, substituting 0. I don't know if that makes sense. So let me put it this way. When I'm substituting 0 here, when I'm substituting 0 here, when I'm substituting 0 here, it gives me 1. When I'm substituting here, it will give me 1 over s, meaning 1 over negative s in this case. So you will see how that turns out. So let me substitute infinity. So the whole thing, whenever I'm substituting infinity here, the whole thing becomes 0 because we are multiplying. So that means it's here it's going to be 0. Negative. Now I'm substituting 0 here. It's going to be 1, and here it's going to be 1 over negative s, right? All over 1 plus 1 over s squared, plus I'm doing the same thing over here. When I substitute infinity here, the whole thing was 0. So 0 minus, when I substitute 0 here, it gives me 0. So everything is just 0 squared. You can rewrite it. But then it doesn't matter because of x0. So this one, this is 0. So now let me substitute this one. Sorry, not substitute. Let me simplify. It's 1 over s all over. So this one we can do it as x squared s squared over s squared plus 1 over s squared. Because of this one is just 1 over s all over, again this one is s plus 1 all over s squared. So now let's simplify. It's going to be 1 over s. It's going to be multiplied by s squared all over s squared plus 1. So the final answer here it's s x squared plus 1. So this is the final answer. And as you can see, let me show you something. As you can see here, our f of t, it was equal to cos t, right? And then when we transform it, it was f of s equals to s all over s squared plus 1. So there is a 1 here. There is a 1 here. This is 1. So if it was going to be, let's put it